access means. Okay, so now let's take a example. There is a man and he wants to go from one town to another. For example, maybe if I want to go from Colombo to Kandy or wherever, from one place to another place, a faraway place. Okay, now in this example I have taken town 1, town 2, town 3, town 4, and then town 5. And imagine this person wants to go to town 5. Town 5, okay? So, as you know, if you want to go to Kandy, you have to go in a vehicle, pass all the in between places and go. You can't directly jump into Kandy. Same way, if this person wants to go to town 5, he has to go step by step. So he will first reach town 1, okay, then he will go to the town 2, then the town 3, then town 4, then only he will reach his final destination of town 5. Now this type of access is known as serial access, because to get to 5 I don't have quick access. I have to bypass all these one by one and go, right? So because of that, time taken to reach any town is not the same. For example, if I want to go to town 1, it will be would have been the easiest one, because that's the first town I see. So I can go there quickly. If I want to go to town 2, it will take a little bit longer, because I have to pass town 1 and go to town 2. Because I have to serially access the town 2. Then I have to go to town 3. I have to serially access town 3. I have to go to town 1, then town 2, and then go to town 3. Okay, same way town 4 and town 5. So that is why this is called serial access. Okay, this is what serial access means. Reaching town 5 will take more time than reaching town 4, because you have to bypass all the places that you're trying to go. Okay, so this is what serial access means. I have to explain this to show you what random access is. So next I will show you what random access is. Now look at this example. In this case, I have not used a person, I have used a processor, because processor is what is going to go and access the memory, right? Now let's assume we have memory locations 1 to 1003. I have put dash 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 to, I mean, I can't write all the memory now, so I'm just taking this as an example. So now we have, in this case, memory location 1, memory location 2, memory location 3, memory location 4, 5, 6, 7, 8, 9, and then 150, then 151, then 152, and so on, so on, so on, and then 1000, 1001, 1002, 1003. So let's just assume this example. Now, if this is the case, now if you look at memory location 1, what does it contain? 25. If you look at memory location 2, it contains -7. Memory location 3, 2.5. Memory location 4, 4. Memory location 150 contains 15. So these are location addresses. These are the contents that is in that location, like houses. Now we have house numbers and people inside the house. So people inside the house are like these contents. House number is like these location addresses. Okay. So now the question here is, how will processor access memory location 151? So if we are going to do a serial access method, then like what we saw in the previous example, first the processor has to go to 1, then 2, then 3, then 4, 5, 6, and go on until it goes to the 151. But that is not what random access is. That is a serial access, okay? So in a random access, what happens is processor can directly go to the location without going into each one by one. So this is called direct access. Okay. So this method is known as random access. If the processor wants to access memory location number 1003, he'll directly just go there. He need not go through all of this. That's the way the computer is wired. Okay. So that kind of wiring is what random access means. And here, time taken to reach any location is same. For example, if the processor wants to go to 151, he'll directly go there. If he wants to go to 1003, he'll directly go there. So the time taken to reach 151 or to reach 1003 will be the same. It just go there. Okay. So this kind of access is called random access. Now, the thing is, even though we are talking about it as random access, this is the same method ROM is also accessed, because I told you ROM is also a random access memory in a way. I mean, now they don't talk about it like that, but the processor can access the ROM also in this direct access method, same as accessing a RAM. Okay, so this is an example I wanted to show you about random access, what random access means, and I also showed you what a serial access means. Okay, so now here we have both. A serial access is to reach a particular place, you have to go through that whole thing and then finally reach. Whereas random access is you directly go there. You don't go stage by stage or anything like that. You go to any place you want direct. And the computer is wired like that. The random access memory is wired like that to go and access, or the main memory is wired like that. Okay, right. Then we will now take a look at the use of this main memory, ROM and RAM. Why do we need a ROM and RAM? Both are main memory. So what is the purpose of it and how does it get used? So that's the question I'm trying to answer here. First, random access memory. Used for keeping instructions and data the processor is currently executing. Okay, this is the place where it will keep whatever the instructions and data that it needs to work with at this point in time. Okay, example, when you are working with Microsoft Excel, I took this example because you all are familiar with Microsoft Excel. So if you are working with Microsoft Excel, then the RAM will have the instructions and data of Microsoft Excel. Then only you can have this worksheet and do calculations and do those functions, because the processor is, or the processing unit is executing or doing the Microsoft Excel instruction and data that is provided to it to do this job. So Microsoft Excel is working. Similarly, if you take Microsoft Word, if you are running Microsoft Word, that means the RAM is having that code or the instructions and the data, and the processing unit is taking instructions from that and doing. Then only you can create Word document and do spell checking on that and saving it and so on and so forth. So all those operations become possible because the processing unit is following a certain set of instruction. Now this is, as I told you earlier, you can't see these instruction set. These are all in the RAM. Okay, right. Now we'll come to ROM. So what is ROM different from, and why do we need this? One of the main use of ROM is to keep the instructions and data required for the computer to start. Right? This instruction and data will be hardwired into the ROM by the manufacturer at the time the ROM is manufactured. That is, one of the main use of ROM is to have the instructions for the processing unit, to tell the processing unit how a computer is started. The instructions and data required a small portion. Okay, I have a diagram showing that in a little while. So this will do the starting up. The instructions and data will be hardwired. So when the ROM is made, like I told you, ROM you can't write anything afterwards. At the time of manufacturing the ROM, the people who are doing the ROM will put those startup code necessary to do that. Okay, and once the ROM is done, it's also fixed into the computer. Okay, the computer manufacturer will build the circuitry inside the computer in such a way that the starting of the computer will always make the processing unit pick the first instructions from the ROM, which has the startup instruction. Okay, that is the reason why the computer always starts the same way, because every time you start up, the circuitry in the computer tells the processing unit, okay, go and pick the instruction from the ROM, and the ROM will have the startup instruction set. So when it starts to follow that, it's happening. That is why every time the computer starts, it's always the same thing. Same thing happens. It takes a while loading all these to have whatever internal things happening, and you come up to whatever the familiar screen that you start working with Word or Microsoft Office or anything like that. Okay, so now I have a diagram showing the startup process. I just thought it's better to show it like that. Now, starting a process works like this. you have the processing unit, okay, and then you have the main memory. Now, this is the diagram I wanted to show you. If you look at it, ROM and RAM make up the main memory. Okay, these two things together only we call it as the main memory. So this is not the secondary memory. The processing unit will be able to work with this as well as it will be able to work with this. Now, this is where the manufacturers have hardwired the startup code, how the computer starts up. The instructions required, a small portion of the instruction required to start up. Okay, and also very important to remember. I have not drawn this proportionately. See, not a proportionate diagram because proportionately this area looks a little big compared to this also. But in reality, ROM will be very tiny area. Proportionately, a very small area of the main memory will be ROM, and there they would have hard coded the startup instructions and data. Okay, and then secondary memory will have a set of the full instruction set for the computer to work. Generally, you can call it the operating system or whatever we want to call it. All those instruction sets are recorded here. They don't put all of these into the ROM. The reason is if they want to upgrade, this file can be replaced with a new upgraded version. Okay, whereas if they put all this into the ROM, then the manufacturers have to come take your computer, remove the ROM, put a new ROM into this thing to upgrade. So upgrading of startup code and startup instructions won't be possible if everything is going into the ROM. So that is why the ROM will have a very small part, and the major part of the startup and other things that is required for the computer to work on will be in the secondary storage saved as one or more files. Okay, right. Then that is the startup. Now we are going to start the computer. Okay, as soon as you start the computer, you will notice the processing unit, the computer's circuits are made in such a way, immediately the processing unit goes and looks in the ROM to get the first instruction. Okay, this is the first thing that happens. So as soon as it happens, startup processing unit starts to work with the instructions that are here. This instruction here says something like startup code in ROM tells the processing unit to go to the secondary memory and upload the startup instructions and data files, that is this one, to the RAM, and then take instructions from that. So basically it's trying to load this into RAM, and from that point on processing unit will take instructions from that, because processing unit cannot work directly from here. That is why it needs to first load it into the RAM and then proceed from there. Okay, so let's see that. See, now the processing unit is, ROM has told the processing unit, okay, read up this particular stuff. So processing unit comes to read this to or give instructions to read it and load it into the, loads a copy, takes a copy of this and puts it into the RAM. So it comes from here, a copy. Okay, so this is still there in the hard disk of your secondary storage. Now a copy of these startup instructions have come here, and then this also told load this and start taking instructions from here. So now it's loaded it, and now it is starting to take instructions from here, and after that the processing unit start to take instruction from this and it starts to work on. So as you can see, the next thing you will be seeing is this, your familiar Windows screen, for example. Okay, as soon as things are happening, now these are all done by this startup code in the RAM. ROM won't have all those things. ROM will have just small information to tell the processing unit, go and pick this, load it up, and take instructions from here. So once that starts to happen, you know your familiar Windows screen, and then you log in, you do all that is controlled by those operating system codes. Okay, thank you very much. I hope I have covered rough basic information